Here we go.
Watch.
All right, the other day we started talking about what? What's that? Corresponding angles and sides. And we were talking about those in reference to what? Triangles. What kind of triangles? All kinds of triangles? Like what?
Like this, the obtuse having that cube and the scalar and the isosceles and the right angle and the equilateral and the
And all those are what? What do we call them? Or the what?
characteristics.
Classifications. Okay, and we can classify triangles by what? How can we classify triangles?
You can classify
Angles and sides. And we put the angles and sides in each of those categories. Then once we reviewed all those classifications, then we did what? When were we looking at the corresponding angles and corresponding sides? Sorry? If they were congruent, how do we know if they were congruent?
Same size shape.
Okay, so we looked whether they were the same size, same shape. What was the same size?
Sides and angles.
The sides and the angles, the segments and the angles. Corresponding sides and angles. Okay, so that's where we left off. We talked about, we just brought up, I do believe, the 5 ways to prove triangles were congruent. Just the letters, we didn't go through. Did anybody remember them?
Side, angle, side, angle, angle. No, not angle. HL, hypotenuse, leg.
Angle, side, angle, hypotenuse, leg, and we got
Angle, side, angle.
We got side, angle, side, angle, hypotenuse, leg, and angle, side. Okay, we are going to look at those 5 things a little bit more in depth today. Well, let's start here. Get our brains moving again. We didn't do this the other day, did we? Right. I didn't think so. Just making sure. What does that mean, QUAD? Talking about. So that you're not frantically writing, would you want me to send this to your Google Classroom? Yes.
Give me about 30 seconds and it'll be up there. Oh yeah, sorry. I guess I should have froze the screen so you could work on that.
Everyone's cell phone.
Okay, if you do have your computers, it is now posted. You should be able to see it.
So you can follow along here or on your computer. Geez, you're only supposed to look at the first page, not the rest. All right, list all the corresponding parts. How many parts is that? 4? 8? Is it any different than when we dealt with congruent triangles? No. When we have two congruent figures, we know that we can list all the congruent corresponding parts. Well, what parts make up a quadrilateral? Same thing, sides and angles. So where do you want to start with first? Sides or angles? Angles. Okay. So which angles are corresponding? How do you know that?
Because they're in the same space.
They're in the same position. Okay, so angle W matches up with, or corresponds with, and is congruent to angle A. What's another pair? What's that? Angle A and angle O. What's another one? What about S and T? Points are congruent. Angle S and angle T. And what's the last pair of angles? What's the last pair? Angle H and angle E. Very good. All right, that was an easy one. Okay, get even a hair harder. Where are the corresponding sides? Crowd goes silent. Yeah, great.
Segment WA is congruent to one segment NO.
Okay, segment WA is congruent to segment NO. Keep going.
Segment SH is congruent to one segment TE.
All right, segment SH is congruent to segment TE. Keep going.
One segment WH is congruent to one segment NE.
All right, one more.
One segment AX is congruent to one segment OT.
Very good. Okay, very good.
Could you say that one segment WS is congruent to one segment NT?
Segment WS is congruent to segment NT. Yes. Could we say segment WS is congruent to segment TN?
No.
Yes. Yes. Because remember, in a segment, WS, so we can call this segment WS or segment SW. It's the same segment. Okay? When we are going and we are naming polygons, specifically triangles and quadrilaterals, when we are matching up corresponding pieces, the vertices have to be in the same spot. Does this thing have a vertex? No, so it doesn't matter. The end point either going this way or this way from W to S is the same segment that's going from S to W. So we can name that both ways. Okay, good question. All right. Well, the measure of angle O is equal to the measure of angle T is equal to 90. The measure of angle H is equal to 36. What's the measure of angle N? Got it? Got it? What is it?
4.
144. Sorry, have that.
Because there's 360 degrees in a quadrilateral.
How do you know?
Because a quadrilateral is composed of 2 triangles. And
Really?
a triangle has 180 degrees.
No.
Yeah, right.
The word? The word?
Yeah.
All right, draw a quadrant. How is that 360 degrees? Where am I trying? Whatever. Unbelievable. You don't need the other ones?
What?
You don't need the other ones?
What other ones?
Well, you did that for 2 of those. I don't have to do it for the other 2.
You could, and then you have one triangles.
Can I find all those out?
Yeah.
I could if we had a little bit more
Well,
information.
you're still adding these angles.
Yes.
So even if you cut them into negative triangles.
Right. We only need one or the other.
Right.
Good job. So if we take these 2, then yes, we are cutting these things so that we can find these angles. Why do we cut it in triangles?
Triangles are funny.
What do you know about a triangle? What about like, what is 180 degrees? The angle of that triangle is 180 degrees? So a straight angle is a triangle?
No.
That's what you're telling me.
The
All
sum of
the,
angles.
put a couple words in front of it.
The sum of
Some.
angles.
Some of these angles, okay? Not an angle, not the 3 angles, the sum of the 3. Why? What does that mean? The sum means what? Adding. Again, we're going back to the semantics of talking the same way, so we're all on the same page. So we know, because the other day we talked about this, the sum of the 3 angles in a triangle, right? The triangle angle sum theorem that we dealt with the other day, says that 3 angles of a triangle always add up to be 180 degrees. Well, if I can make triangles, I can get 180 and 180. Well, 180 and 180 is how much?
360.
360. How many of you guys remember the formula to find the measure of the interior angles, no matter how many sides a polygon has, higher than 4? What if I said find the sum of the interior angles of a 20-sided figure? Do you remember how to do that? What is it? 180 times n minus 2. What's n?
There's no sides.
Why is that?
Because
Start here. If we have 3 is the smallest polygon that we have. We go to 4. Well, when I put, what's that one piece called? You know what that's called? How's that called? Where's it going? A what?
diagonal.
The diagonal. It's called a diagonal. A segment in a polygon that joins 2 non-consecutive vertices. All right, so a diagonal is a segment, I can spell this way, in a polygon that joins 2 non-consecutive vertices. Okay, so when I have all of the diagonals drawn from one vertex, I only need to do it from one vertex. So let's see. Octagon. By this, how many triangles will we have? 6. Now, there's also a formula to tell you how many diagonals you have. See if you can figure that out. But if I have 1, 2, 3, 4, 5, that gives me 1, 2, 3, 4, 5, 6. How many diagonals do we have? We have 5 diagonals. How many sides did we start with? We started with 8 sides. We had 6 triangles. We had 5 diagonals. We had 4 sides. How many diagonals? 1. How many triangles? 2.
Is it time?
Well, what did the n minus 2 give us? Number of triangles. How many diagonals?
1 more. 1 less than that.
1. What's 1 less than this? N minus 3. So you can find the number of diagonals from one vertex by saying n minus 3, number of sides minus 3. Okay. Well, when I have 1, 2, 3, 4, 5, 6 times 180, what is 6 times 180? 1040, 1080,
Yeah.
1080. Okay. So do I need a diagram anymore to know what the sum of the interior angles are? No. Now, the little catch here is that it has to be a convex polygon, not a concave polygon. Okay, convex polygons are your traditional polygons, not ones that kind of bend in on themselves. Okay? All right, so back to this problem. We said we had 360 degrees. Well, great. How does that help us? Do I know what this quadrilateral looks like?
No,
No, does it matter?
no.
No, absolutely not. So if we go back to this and I just do two quadrilaterals, okay, four-sided shapes, make it easy, W, A, S, H, N, O, T, E. Can I do that? Yes. Measure of angle O is equal to the measure of angle T is equal to 90. 90, 90. Measure of angle H though is 36. Trying to find the measure of angle N. Well, I give you two angles in that quadrilateral, and I give you one angle in this quadrilateral. What good does that do me? Yes.
Take angle ES 36.
How do you know that? They're corresponding because angle E corresponds to angle H, and if they're congruent, we know about angle E and angle H. They're congruent. And if this has a measure of 36, exactly. Measure of angle E has a measure of 36. Well, great. What do you know about measure of angle M plus the measure of angle O plus the measure of angle T plus the measure of angle E? What do we say about it? Add it up to 360. Now, we're not in geometry class anymore. Where are we? Back in pre-algebra, because now what do I do? Instead of measure of angle N, what do I write? Do I know that? No, leave it as a measure of angle N. Stay away from that nasty X. Okay? Do you know the measure of angle O?
Yeah.
What is it? Sure. Plus 90, plus the measure of angle T. 90, plus the measure of angle E. 36 equals 360. Well, 90 and 90 and 36. 90 and 90 is what? 180. 180 plus 36, 216. Measure of angle N plus 216 is equal to 360. Now what? Okay. Subtract what? And get it. All right, you got lucky. You're right. Good job. Questions? So again, some of the stuff that you have done in the past is coming back, slowly mixing in with the things that we are continuing to add on to new things. All right? Awesome. Now, we take a step. All right. Because now we go back to these guys. These are the five that we had the other day, yes? Now there are a few more. And some geometry teachers go through those. I don't. There's kind of being redundant, yes.
Why isn't there one called angle?
Why isn't there one called angle, angle, angle? That's a great question. Let's look at that. Why isn't there one angle, angle, angle? Well, Why wouldn't they be congruent?
The side could be a lot bigger.
And still have the same measure of the angles?
It could have.
How's that possible?
Because the angles don't matter.
They don't matter.
They don't matter when you compare the sides.
Well, why do we have to match them up if they don't matter?
Doesn't matter how big the sides are.
You sure about that? Then why do they matter when we get congruent?
Because never mind. Okay, got it, never mind.
Well, now you got me curious. What?
Because it was ridiculous. Because if they were different sizes.
Well, that's what he said. It doesn't matter. How does it not matter?
Because an angle is created when two lines intersect each other.
Yeah.
If two lines could intersect each other and they could be different sizes, but the angle created between the intersections is the same.
What's that have to do with the triangles then?
Because the size of the triangle could be different, but they could still.
How?
Because they could be bigger or
Is that again?
smaller.
Do exactly what you just did. Where have you done that before? Almost every single day of your teenage life right now. Do it again. Show us. When do you ever do that?
Never.
Well, that.
Do what?
Yes.
I've never done this.
Yes, you certainly have. You might not do it with 4 fingers. I guarantee you do it with 2.
Go zoom in.
Yeah.
Oh, they got an iPad.
When you zoom in on your phone or on your tablet, what happens?
It gets bigger.
What gets bigger?
The screen. Well, the screen.
Oh, the image,
Like,
the image.
If I have my arm in this angle, when you zoom in, does the angle of my arm go like this? No.
Sides.
No, yes.
My length of my arm changes. If you zoom out, my arm either gets really, really small, or when you zoom in, it's really big. Zoom in all the time. It's okay. Okay? No. That's what happens when we go and we magnify something. Either magnify it to make it bigger or shrink it to make it smaller. Okay? We don't change the angles. Therefore, with congruence, there is no angle. Because even when the triangles are really, really, really tiny, we can have the same angle measures here as here, but obviously these two are not congruent. Okay, great question. All right, a little bit more review here. So what I've done, and I'll give you a chance, some of you guys are copying this down still. You can make this table. We're going to go through, we're going to fill in these 5 little blanks. And I will tell you, the first 4 all start the same. And they all end the same. They actually all 5 of them end the same. So you guys are ready, I'll let you catch up so that you can pay attention when we're doing this. Good thing they wrote that on there. You might not know.
I forget.
I don't know. Water. Good evening. Might know that. This water's so sweet.
It's so considered. They write down people with no sense of smell.
They are nice like that.
Thank you.
My favorite one is the ones that are printed on the bottle that say, authentic artisan well water. You know what that means?
So offended.
Oh, that means they turned the tap on and filled up your bottle. And I want to know where this gigantic stream is that they fill up all these avions in Deer Park and everything like that. There's no stream. That stream is seriously dry by now. There's no stream that's going to fill up these billions of water bottles.
In America, isn't there something like smart water?
I've never met a bottle smarter than me. But yes, in America, there's a lot of different things. There's smart water. There's what is it? What's the one? Which is kind of like Gatorade, and it's water. Oh my gosh, I drink it all summer.
Well, that bottle.
They call it mineral water or something. I don't know. Vital.
Oh.
It's good. It certainly is not water. Never seen any purple water. I just see that street. Seen some green water. All right, I think we're good. Everybody's great. Okay, SSS. We said that stands for what? Side, side, side. Now, in terms of congruent triangles, because that's what we want to get here, how would we put this into words?
All corresponding sides are equal.
All corresponding sides are
Congruent.
congruent. There you go. So, in two triangles, if all three pairs of corresponding sides are congruent, what happens? What happens if all three pairs of corresponding sides are
Then
congruent?
the angles are congruent and
And the triangles are congruent. Now, does this mean that we have equilateral triangles? All three sides that are congruent? Can it be equilateral? Yeah. Could they be scalene triangles? Can I have two scalene triangles that are congruent? Why? None of the sides are congruent.
No, but they're corresponding sides. The next triangle.
That's the key. It's not within the single triangle, it's between the two triangles. So even though all three of these sides in this triangle are not congruent, this is a what type of triangle? What happened? What kind of triangle has no sides congruent? Scalene. Well, that means that two scalene triangles can be congruent if all three pairs of corresponding sides between the two triangles are
I have a question. Shouldn't we all just use one of these to see if triangles are congruent?
good, but sometimes we don't have that information.
Oh, so.
If we prove two triangles are congruent using side, 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 I do not have to use any of the others. Because once I get them congruent, I don't need to prove them congruent again. So if I get them using this, then yes, I could get some other information and, oh, well, now I can say it's a, yes, you could, but we don't need to be that redundant. Once we get it the first time, we don't have to prove it again. Yes.
How do you know if it's angle, angle, side, angle, side, angle?
Brain animal, but we're going to talk about that. Trust me. Walk before you crawl. You got to crawl before you walk. You can't go sprint a mile if you can't even walk 10 steps, right? Right? Get that firm all up. All right. Obviously, you have some cats. Side angle side. Don't pick the nose. That way on camera. Side angle side. What does that mean? Two sides. It kind of goes with the question. Two sides and what? What about them? Are they corresponding or are they congruent? Don't like these guys, they don't know. What do you know about these sides? Are they corresponding? Yeah. Are they congruent? Yeah. Well, what about that angle? Which one? Which one? The top one. Always the top one? So I can only use side angle side when it's the top angle? What happens if it doesn't have a top?
It should be.
There you go. This is where we get tricky. Side angle side. So in two triangles. Again, between two triangles, when we're dealing with two triangles. If two pairs of, as Justin said, corresponding sides, and wait a minute, where's that angle? Top, only the top?
The middle
Middle. Now, middle of what?
of the other two sides.
In the middle? So what happens if the side is like this? Is that in the middle?
No, like in
You said it was in the middle. Between. Now, when we're dealing with angles and sides, we don't use the word between. Okay, we can think about it as between, but that's where our language gets a little fouled up. We don't want to use the word between. We want to use the word included. Because when I look at this angle, how is this angle formed?
by the intersection of those two sides.
By the intersection of the corresponding congruent sides. So we call that included. Okay. So in two triangles, there are two pairs of corresponding sides, and their included angle are congruent. What happens? Triangles are congruent. I'm shortening this.
Got all lazy there.
Okay. So now we learned a new word. Included. What does that included mean? Between. It is made up with or lies between the sides that make it up. Okay. Because the sides that make this angle up are right here. Those are the ones that are corresponding. Oh my gosh, there's a steak in your boot. I'll move that one. There's a steak in my boot.
Oh, is there the toy movie?
Toy Story.
Toy Story. I couldn't think of the movie.
There's a snake in my
I was gonna say Toys R Us, but then it's not me.
Oh, if you do it.
Yeah.
And this going to this.
Absolutely. Yes. Once we're done with this chart, we can transfer this chart and put it in your toolbox. These are very important. Okay. Now, the good thing about that is we really concentrate on the first and the last columns. The words are just taking that picture and putting it into words. Okay? You're not going to have to regurgitate what's in red. Okay? Yes, spew back to me. Okay? It's a very nice word for throw.
Yeah.
Diarrhea in the mouth. Yes.
Where do you find it here?
Where do you find this video? I'll post this video on your classroom. It won't go automatically. It's got to take a little bit of time to process, but you'll see it as a YouTube link. Okay. Good question. All right. So now we got side, side, side. We got side, angle, side. Now, what's the difference between side, angle, side, and angle, side, angle? Come on, point out the obvious. What side, what angle? That's it. The only difference is where this one says side, this one says what? Angle. So instead of creating the angle, instead of the sides creating the angle, what happens? The angles are, in a sense, creating the sides. So what kind of side is this?
Sides. Oh, included.
There we go. So this side is included between these two angles. So literally, all we have to do is go back to this one and interchange the words side and angle. Okay? So, in to, not try sides because that wouldn't make any sense, but try angles. Right over your head there. Will you bobblehead now? Okay. If two pairs of corresponding what? Angles now. And they're included, they're included side this time, are congruent, then the triangles are, ugly word, congruent. Okay, so literally we just interchange interchange the side, made it an angle. Change the angle, made it a side. Change the side, made it an angle. Now we're to the question. What's the difference between angle side angle and angle angle side? Both of them have a pair of angles, two pairs of angles, and both of them have one pair of sides. Well, my response to that is, what is the difference between ASA and AAS? Literally, don't overthink this. What's the difference between ASA and AAS? The order. What about the order? What's the switch? These two? What does this stand for? And this is angle. What kind of side did we say this was? Included. Now we're going to move down there. Is this side now included? No. Well, we don't want to be rude. We don't want to exclude. So we're going to be a little less harsh than Rhea and say not excluded. We're going to call it non-included. Okay? Because I'm not as mean as some of you guys. All right? Now, there is a little trick here, though. Because this one starts off almost the same way. Into triangles. I told you these all start off the same way. If two pairs of corresponding angles and we just don't want to say they're not included. We want to say they're corresponding not included. Okay? And I know that sounds a little funny, but I'll show you why. They're corresponding non-included sides are congruent. Then what happens? We're getting the hang of these. Okay? Yes, sir.
What if the bottom side is like our corresponding? Is it slower?
Bottom side. I'm going to assume that we're talking about the same kind of diagram here. So I will do this one, and that. Yes. Okay. Well, let's see if it fits. Does it fit the criteria? Do I have two pairs of corresponding angles? 1, 2. Are the pair of sides that I know in the same position? Are they touching one marked angle to the no marked angle? Yes. So are they the corresponding non-included side? Yes. Well, what's the difference between that and that? Is it the same?
But they're still congruent.
They are still congruent, but are they in the same position?
Oh, no.
No, they must be in the same position. Okay, that's why we had to throw this piece in. Okay, we didn't have to throw that piece in here because there's only one side that's included between these these two pairs of congruent angles. There's only one side that can fit. Over here, we can very easily see that there are two non-included sides. So we've got to make sure that it's the corresponding non-included side. Yes.
So in angle side angle, the side has angles on both sides of it?
Angle side angle, the side has angles on both sides.
Whereas angle side, the side only has an angle on one side.
Yes.
Why do we say like non-included and not excluded?
Like I said, we're not rude. We're not, you're excluded. No, we'll just say, we're not going to include you. It's a little less harsh. Same reason that they say it's a right angle instead of a left angle.
Yeah, why is it a left
I don't know, the world's against left-handed people, I'm telling you. How many guys are left-handed, by the way? You ever try to put money in a vending machine left-handed?
Yes.
Yeah, you gotta turn your hand upside down like this. Yeah, you right-handed people think that's funny.
It's not
It's not so funny, all right? You gotta stand to the side and we gotta tilt our arm like this because our right hand doesn't feel funny. We stand like this. It's not funny. It's a little bit embarrassing. Why can't, I'm gonna make a soda machine where it's left-handed. I don't laugh at all. Like right-handed people, they gotta go like this. I don't do that.
I'll use it.
I'm sorry.
I'll use it.
I would too. And seriously, you guys don't realize how right-handed this world is.
Yeah, look at this binder. How am I supposed to write like? No, but it's the same for us. Like you write.
Sadly, you know why I write right-handed? I was forced to write right-handed. I can write left-handed.
Whoa, you're such a-
Okay? But in kindergarten, I was forced to write right-handed. A little history story for me.
They wanted to kill us.
Wait, so can you write with two hands at the same time?
I'm amazing.
Can we see?
No, you think you can't read this? You will not be able to read it. Okay, that one I cannot. Well, I don't know. I've never tried it, to be honest. But I can write left. It's not very pretty, but I can write left. And my left-handed is not an overhand left-handed. My left-handed is a right left. All right. Yes.
Why isn't it SAA?
SAA. So we don't like that. We go alphabetical. Yeah. Really, it doesn't matter, to be honest with you. You could go, you know, if you want to be a little dyslexic, you want to be a little different, fine. SAA. It's okay. No, to be honest, I don't have any other explanation for that other than alphabetical. Okay? There's nothing against dyslexia. Sometimes I feel like I have a little dyslexia, but that's okay. All right. Angle side. I don't have any justification why it's AAS versus SAA other than alphabetical. And only English alphabetical. No idea. Okay. I guess if you're Arabic, you read right to left, hey, it's in SAA. I really have. I got a question. Yeah. So I'll see who hits who first. Yes. Okay. Now I have this last one. What's so different about this last one?
It's only works for.
Starts with an A, and not an S or an A. That's anything past her, she's a quick one.
It only works for right.
Why only right angle?
Because you can only use like Pythagorean theorem to find hypotenuse for a triangle that's right angle.
All right, a little bit too much information in there, but let's look at what you said down. What kind of triangle has a hypotenuse?
A right angle triangle.
A right triangle. The only triangle that has a hypotenuse is a right triangle. So this will only work for triangles that have a hypotenuse. Because what's hypotenuse? Start with. Think, what are the other parts? What are the other sides in a right triangle called? Legs. I'm telling you, they're genius. Mathematicians are amazing. H for hypotenuse, L for leg. That's awesome. Okay? So, leg, like, yeah, you got two of them. Well, we have two. Some people only have one, some people don't have any. So it's HL. No, eyes are up here. H-I-P, hypotenuse. No, we don't test how to pluralize hypotenuse. Where's the hypothesis? Where's the hypotenuses or hypotenuse?
Hypotenuse.
Back to the plural of mouse is mice,
Hypothesize.
but not the plural of moose is not meese. We're mooses. And then how come sometimes when we have a word like deer, D-E-E-R, the plural of that is, hey, there's one deer, but oh, guess what? Then there's 200 deer.
And fish. But what about sheep?
Fish, but then we have fishes.
No, what about sheep?
Sheep.
Is it one sheep, two sheep? Yeah.
Yeah. One sheep, two sheep, three. Don't fall asleep.
But what about fish? Except I want fish. Yeah, like 5 fish.
But how about fungus?
Fungi.
Fungi. Yeah, I am a fungi. English doesn't make any sense. Exactly why we call this a shirt, but we call this a pair of hands.
Wait, no, that makes sense, 2 legs.
2 Well, they're, you know, here's even one better. Why you park on a driveway, drive on a parkway? Why do we go to a sporting event and we sit in the stands?
Oh, I get it.
It should be called the sits.
You didn't get it.
English totally does not make any sense, which is why I'm probably going to explain to you. Yes, because there's too many things that don't make sense. All right, all kinds of stuff. We get to talk about this all year. I love it. Okay, reel it back in. Let's focus because today's Tuesday. We have a little bit of a short period. Hypotenuse leg. So now, these 4 up here work with any triangle, including right triangles. These work with any triangle. This one only works with right triangles. So we're going to start this off by saying that. Into right triangle. Okay? Into right triangles. If the hypotenuse and the corresponding legs are congruent. Then what happens? Yes. And the right triangles are congruent. I just want to emphasize right. Yes.
Is this like, can this also be the same side angle side?
Not side angle side. Why? Where's the angle in side angle side?
Oh, it's supposed to be included.
Side angle side, the angle is included. where's the angle here?
Non-included.
Not included. And what happens when we write the non-included angle? And we can't have any bad words in geometry, so. This is a mathematician's way of saying a bad word.
Oh. So like, you don't.
Yeah, because we can't say this.
Hypotenuse means angle.
No, hypotenuse is the longest side, opposite of the right angle. Okay? Hypotenuse, does everybody know that, what the hypotenuse is, where it is? The hypotenuse is the side in a right triangle that is always opposite the right angle. Okay?
So no other kind of triangle has a hypotenuse?
Oh, right triangles are special. They have two legs and a hypotenuse. Now, another kind of triangle is just as special that we're going to deal with next time. Actually, I have a lot of things that are special about this. All right, so we're good on it. Here's all the explanation. Like I said, this column and this column are the important pieces. This is just to put into words what's going on in these two columns. Yeah. Okay. So we are going to use this column and this column. Now, obviously, this is a very basic layout. We're not going to get lucky all the time, and our triangles are going to be side by side, maxed up perfect. We're going to have to turn. We're going to have to flip. We're going to have to twist and flip. We're going to have to have triangles that overlap each other. We're going to have triangles that share parts of the sides. We're going to have different things that are going to be going on in the diagrams. We're not going to have super simple diagrams that look like this all the time. Okay? So we are going to have to look a little bit deeper sometimes. Now, sometimes we are going to get lucky and it's going to be right in front of our face. But most of the time it's not. Okay? So what we're going to do now is we're just going to practice. Everybody got all this? I can erase what's in red? Because I can't what's in blue. You guys didn't even get that. Look at me in that sound voice. Woo! Way back. No, he's not falling asleep. Are you kidding me? It's amazing. All right. That's awesome. You like my clap? I broke my clapper. I used to have a clapper until I clapped on. Broke it. You basically do clap? No. Never had a clapper. All right. State if the two triangles are congruent. All right. So let's see. Just so we can.
Sorry.
Just so we can see, because the red didn't come through as well. I'll give you a second to comprehend this, and then we'll go through it. And again, you don't have to frantically go through this. You can make note that this is already posted September 6th on your classroom, so you can refer back to this for the diagram. We have time to digest, think. What do you think about that first one? Congruent or no?
Yeah.
Now, before we go any further, when it says state if the two triangles are congruent, and then it says if they are, state how we know, keep in mind, you do not need to write a paper about how you know. All right? How do we know if two triangles are congruent? One of those 5 things. That's it. All you got to do is write side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. We do not need to write a whole doctoral thesis about why these two triangles are congruent. Okay? So I know some of you guys really think that sometimes that's what you got to do. You got to write. You got to write everything. Okay? You don't have to. All right? So, are the first two congruent?
Yeah.
What?
Yeah.
I only got 2 pieces of information. So, hypotenuse leg. Why not? It's the only one that has 2 pieces of information. So, why?
Because there's no on the side. I mean, that's like.
Well, there's only 2 pieces of information, and I can't use hypotenuse leg, so you tell me these two are not congruent. Right? Gotta be right. It's the only one that has 2 pieces of information.
No, but they share a side.
So-
Like, you know that that's equal. I mean, congruent.
What?
No, I mean like they share a side, so
So?
it's the same
One's the same
measure that they propose.
So now you
Ah,
have to-
If 2 triangles share a side, what do you know is true?
That is have 2 same sides.
Why? What property is that? When we talked about the other day. What says, what happens when we say, identity? What do you see when you look in the mirror? Reflective property. Reflexive property. The reflexive property is going to tell you that all segments or all angles are congruent to themselves. This is where that comes into play. So, yes, that is true. That is congruent to itself. Now, the question is, just because it's congruent to itself, is it in the same position? Is it not only congruent, but is it in the same corresponding position?
Yeah.
This is where our spatial ability comes in. If I can grab this, pull it out that way,
Oh.
Yeah.
Yeah.
going this way, are the pieces going to be in the same position?
Yeah.
Okay, so which one of these fits in? Do I have side, side, side?
No.
Do I have side, angle, side?
No.
Is the angle I know included between my angle, or between my sides? Is it angle, side, angle? Is it angle, angle, side? No.
But it's not. But like,
Oh, it's not.
but
Do we know?
it's just but it looks like it, but it's not.
Oh, it looks like it, but it's not. I don't know. It might be, because we do not have any that says side, side, angle.
It's not drawn to scale. We can always get a ruler. It's
So if it's not drawn to scale, then what good is a ruler?
no, it's it's not drawn to scale. So
I think it was that one. That's okay. No, this one is very deceiving. Okay, we want to say it's congruent, but we don't have enough information to say that it is congruent, so we can't. It very well might be. It might be a right triangle.
We can't have any options.
Well, we can't prove it, and if we can't prove it, then we can't say it's for sure one way or the other. So, not enough info. Okay? Might be, we just don't have enough info. Okay?
How could it not be?
How could it not be?
If both sides are different measures. Like that.
Because
4, that could be 5.
these, this angle, and this angle, we don't know if they're congruent. Or this side and this side, we don't know if they're congruent. And they can change. Okay, they can change. Right? Even though these two sides are congruent, and these two sides. Well, I should say these two and these two sides. All right. How about that? What? ASA. All right, Justin's going out on a limb. Says ASA. Okay. Those two angles aren't congruent. But if I turn this around and flip it, now angle and angle. Okay, where's my son? Smarty shaving. The share side. So now angle, side, angle. Good job.
Side, side, side.
What? How?
Because the share side and they have the other sides.
Alright, so you got it. Side, side, side. That one's easy. Alright. Side, side, side is pretty easy, right? I mean, it's a dead giveaway. You got all three sides and everything. Boom. There you go.
Angle side, angle.
What?
Yeah.
No way.
Because they got opposite.
Or you go
angles.
What?
Yeah.
What?
Yeah.
Yeah, what?
Yeah.
I don't understand. You? I don't understand either. What do we have? How angle side angles? Vertical. What vertical? What? Where? Vertical angle. What do you know about all vertical angles? Congruent. Now, why do we have to mark that with 2 marks?
Because otherwise it's safe.
Because this is already marked with 1, and we want to make sure that we don't confuse and say that these 2 angles are congruent. These are congruent, so we put 2 marks. So now, angle, side, angle. All right. You see how these work now? All right. So they can't stay this simple, right? Yes. Bring on challenge. Challenge accepted.
Okay,
Challenge accepted. All right. Oh man. No longer do they share stuff. Well, that actually possibly could make it easy. What about number 5? Is that side, side, side? No, it's a side, angle, side. Angle, side, angle. Come on, angle, angle, side. Gotta be hypotenuse plate. Once again, it could be congruent, we just don't know. Not enough info. Told you, you get a break, you're already on your Google Classroom, you don't have to draw.
Oh, that's the hypotenuse one.
Ah! Number 6 is the right triangle. Finally, we get to use hypotenuse plate. Right? Sure, don't agree with me. I don't know what I'm talking about. All right, so number 6 says that it's a right triangle, so right away, gotta use hypotenuse leg.
It's angle side.
Why? What? What do you got against hypotenuse leg? Does it? Do you know anything about the hypotenuse in either one of those triangles?
It's not a hypotenuse.
Oh man, really wanted to use HL.
It's angle side.
I don't see the angle.
Vertical, the opposite.
Vertical. Oh, we got vertical. Okay, where are the other angles? What do you know about all right angles?
Why couldn't they have the same hypotenuse? No, but I can still angle side angle.
Well, where's the other angle?
It's vertical, right?
What do you know about right angle? All of them? So they're all 90 degrees. What do you know about all right angles? Oh, okay, so all right angles are good. So we've got angle, side, and then we do have some vertical angles here, and then we got angle side. So that is good. Not HL. That's a pitfall. That's a trap. Okay? Just because it's a right triangle does not mean that we're going to use HL. Okay? Now, there is another one specific to right triangles, corresponding leg and corresponding acute angle, but LA, corresponding leg and acute angle, is the same as what? Angle, side angle. And again, it's all about simplicity, it's all about matching things up. I don't need this because it's being redundant. The only one I truly need for right triangles is that one. These 4 work no matter what the triangle is. Okay? All right, what about number 7?
Side, angle, side.
Side angle, side.
No.
You sure? You just said side angle, side.
It's
Now you
not. I
changed
changed
your mind.
my mind. It's not side angle, side.
It's
Because
not side angle, side. Side angle, side. Side angle, side.
the other one's not included.
What's that?
It's being believed. It's like excluded. It's not.
Hey, you're the one that said it's excluded.
I said it's not included.
It doesn't fit side angle, side. Okay? Because here, where's my angle? Here my angle is included between my sides. Here, where's my is my angle included between my sides? No, my angle is not included between my sides. So even though we have 1 pair of sides, 2 pair of sides, and a congruent angle, the angle is in 2 different positions, therefore it cannot be side angle side. Okay? Tricky. All right.
Nothing.
What?
They're not congruent.
You sure about that?
Yeah, I mean one's like different than the other.
No, wait a minute. 1, 1, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2.
Oh, never mind. It looks like it's not, but it is. Or maybe then you don't know notes.
Sure I do. Side, side,
How do you know that those are corresponding?
Because they are the long one is like.
But they're like different shapes. So the second
I don't know that one. They're both triangles.
No, like different sizes. Like one's longer and thinner. And
This one will come back to order. Here. Forgot about it. Order. Okay. This one comes back to order. So, A, B, C, D, E, and F. Can we say triangle ABC is congruent with triangle DEF? Triangle ABC though is congruent to what? What vertex is going to match up with A?
E?
So A is the vertex that is where the 1 mark and the 2 mark is. So where's the 1 mark and the 2 mark? E. Vertex B is where the 2 and the 3 mark is. F. And then C is where the 3 and the 1, and then 3 and the 1. So even though it doesn't look like it, we can match up and get 2 congruent triangles. Okay. Good deal.
So they can go to.
They are.
Side to side.
Side to side.
So whatever they look like, just do the opposite of that.
Don't go by what it looks like. Go by what you can prove. Okay. Don't think it goes into class.
Who's the camera knows?
All right,
Of course.
running out of time.
All right, I'm gonna do one of these, and then I'm gonna give you one problem, because we are short on time today. All right, this is going the opposite. Now I'm gonna tell you, I wanna do angle side angle. And if I have this and I have this, what is that one piece of information that is missing in order to use angle side angle? Which angle? Now, we can be specific because we got U, D, T, and S as the vertices.
TUS.
Angle TUS,
And DUT.
angle TUS, and what about
It should be congruent to angle DUT.
it? It has got to be congruent to angle DUT, she says. Angle TUS and angle DUT. Are those congruent?
Well, they have to be.
Wait a minute, you started out here at T and went to U and then the S, but then over here you went from D to U to T. Is that okay? This is perfect.
Yeah, that's what I'm saying.
Because this angle, DUT, is the same as angle TUD. It's the same angle. This angle, TUS, is the same as angle SUT. It's the same angle. So the way that we name it, again, as long as that vertex is in the same position, and the way, the path, the sides are the same. Okay? All right, now I'm going to take it up a step further. Now, ready for this, Justin? I'll blow your mind.
You ready?
This one you're going to have to write down. Two problems. Oh. Okay. I will tell you that you can do this by paper and pencil, and you can also do this by GSP. I want you to do one by paper and pencil, I want you to do one by GSP. If you have GSP. If you don't have GSP, then you can do it obviously by GSP. How do we do this?
I don't know, I was gonna look it up on YouTube. Khan Academy or something.
I don't know. There's what? YouTube? What are you talking about? Okay, so we have triangle ABC with the vertices. -4, 2 for A. B has the coordinates -3, -3, and C has the coordinates -1, 0. Triangle CDE has the coordinates for C, -1, 0, D, 4, 1, and E, 1, 3. And the question is triangle ABC congruent to triangle CDE? What would you like to say? Do I have water?
Yeah.
Right there on my table.
What thing?
Table. Hey, love you. All right, how do we do this?
You need to plot the points first.
Okay, we can plot the points first. Then what? What? Distance.
Or
How do I use the distance?
just
Oh, no.
But the points and use the distance. What am I going to calculate as the distance? How do I calculate the distance? As long as I move my lips, I'll never know what I'm not saying. Yes?
You could just calculate the distance between A, B, and C, D, and
How?
C. Using the distance formula.
Oh, what is that?
X2 minus, or no, yeah, X1 squared plus squared Y2
Read it.
Y1 and then like the square root of all of
X2 minus X1 squared plus Y2 minus Y1 squared.
and then you
Yeah. Remember doing this last year? Remember doing this maybe a week and a half ago when I gave you that formula? Should be in there. Remember I wrote that one down, or we should have written this down, the midpoint formula, the slope formula, and then we went into all the point slopes. Oh, well, midpoint, if you didn't write it down, might want to write it down now.
Wait, what was the other one?
Slope. Why do you not have these? So this one is distance, and this one is midpoint. Okay, so yes, by hand, because we were going to do this by paper and pencil the old-fashioned way, which is what I want you to do one of these with. I want you to calculate, okay, x2 minus x1 squared plus y2 minus y1 squared. I want you to find your distance. How many distances are we going to have to find? Not 3, not 4, 6. Why 6? 6. Because there's 6 sides. There's 1, 2, 3, 4, 5, 6. You have to do this 6 times. Okay? So find 6 distances. How are you going to determine if these two triangles are congruent? If you have these 6 distances, to see if it fits in the side, side, side. So do one by paper and pencil, find those 6 distances. The second one, I want you to figure out if you can do by GSP or your calculator, which you can do both of them. You can plot the points and then use the same idea, right? But use GSP to calculate the distance. Okay? Yeah.
Could I use my graphing calculator?
Yes. This midpoint formula, just maybe we didn't go over this, maybe it'll take from the other class. The M, remember it's a point. So how do we name a point? By a capital letter, okay? And typically our midpoint is capital M. So we'll have an X coordinate and a Y coordinate. Well, a midpoint is just the average of the X's. You have 2 endpoints, so you have 2 X coordinates. Add them up, divide by 2. It's the average X and the average Y. That's your midpoint. Okay? We'll get more practice with the midpoint in a little bit. There's some special things that come along with the triangle that we're going to do. So you're going to have to find the distance from A to B. You're going to find the distance from B to C, and then A to C. And then you're going to have to find. Yes, so copy these down. It's these 2 problems, and I will post a couple extra problems in yours. Yeah, you can take a picture of anything you want. Yes, because we're out of time because you guys. Okay. Yes. Next class.
I've got to record them. I got to put them in the grade book.
You don't come.
My